Okay, this is a quick tutorial on downloading video from YouTube and turning it into a 3D model using Pix4D. This is a sample page here, so this is White Top Mountain. I'm preparing this for Riley Harris. This is just a drone video of the area, and we want to see if we can capture this detail and turn it into a 3D model. So we're going to grab the video URL and just paste it into any online video converter. It's going to convert the video, in this case, to an MP4, which we're going to then download. And actually, I'm going to save this stuff in here. Okay, we're certainly not going to install any of these horrible plugins. Okay, so that has downloaded and is here. Now the next step is to extract these as video frames. There are a couple ways to do this. What we're going to do is do an install of FFmpeg. So FFmpeg is a free piece of software that will basically you can interact with video in a ton of different ways. You can put video together. But one of the really great things about it is that you can extract all kinds of frames from video. So this is what I use. There's a Git clone if you really want to work on it. We're going to just download Windows builds and download a 64-bit, which is what I've got. The current version is fine, so we'll go ahead and leave that where it is and then download this build. I'm going to download it here for now, although it probably won't stay there. It's not such a big file, 61.5 megs, so relatively small. And you're just going to unzip this. And what we're going to want to do is access just FFmpeg right here. Now we can either do that directly or we can put it in our path, and since this is a tutorial video, I think it's probably worthwhile to show how to put it in a path. So I'm going to copy this and put it in my Windows. It doesn't really matter where you put this. I'm going to put it in Windows Programs just because it's kind of a handy spot here. You do need admin access to do this. And instead of this long file name, I'm just going to call this FFmpeg. All right, now why did I do all of that? The reason is that I want to save this directory as part of my path. A path is a list of directories that your computer uses to sort of behave as if it's in the current directory. So if you want to run a program, it looks in its current directory first, and then it looks in anything that's a part of the path. So we're going to go into Advanced System Settings and Environment Variables where the path is defined. You've got a path here, which is path variables just for me. And then there's a system-wide path down here. So we're going to edit that. You can see that I have a number of other things in here. I'm just going to add a new piece here and paste the directory to the binary file for FFmpeg. And I'm going to hit OK. What that lets me do is when I open a command window now, I can type FFmpeg, and it's going to look and it's going to find that directory or find that file in the program directory and run this information. So now we can go to our OneDrive and we're going to be able to interact with this here by extracting that. So in a previous lab report, I detailed some of this process, so that's why these things are useful. You can go back and rewatch this stuff or see how this stuff worked. In this case, what I want to do is essentially just copy this, which is the command that I'm going to use to do the extraction, and paste it in here. Now the difference is, I'm going to hit the up arrow there to bring that up. The difference is that I don't have a file called dgi0431.movie. That is the file that I had used during the sample, so I need to replace that with White Top Mountain here. And then I can add the rest in here, .vf, FPS, frames per second equals 1. So I'm going to extract 1 frame per second, which is often good enough depending on how high it's flying. We could maybe put that at 2, which would be using a frame every half second, which would be more than enough. And then out %o3d.jpg. And what that's going to do is it's going to extract 2 frames per second, and it's going to save it as a file name with 3, let's call them decimal places, 3 digits worth in JPEG format. So we're just going to hit OK here, or hit return. And okay, this is a rough jump here. I'm interrupting that run because that run ended up producing JPEGs that were not of sufficient quality. So I wanted to bring up 2 things that you can do to improve that. One was to download a higher resolution video to start with. So this video that we had before, that we just downloaded, that I showed previously, is a 720p video, which is pretty good. You can look at these images; they seem pretty sharp. So those are okay. But if you download YouTube Downloader HD, you can actually download the 1080p version. So this is an application that you download and install rather than just go to a web page. I did that. It ended up working just fine, and you end up with a 1080p data set that looks like this. So just a little bit crisper and clearer, and that really is probably going to make a bit of a difference as you do the image reconstruction. The second bit here that's important to pay attention to is this Q scale parameter. What we want to do is try to peg this to the a really nice output quality, and that's again just so that we're getting the highest quality image that we can work with. Ideally, I would probably write this out as a PNG, which has no compression. Well, it has compression, but it's not lossy. But Pix4D doesn't read that at this time. So we're going to, I've got that queued up here. This is the command that you end up needing to use. So this is ffmpeg. We're bringing in the 1080p version. We're setting this Q scale parameter to, I had it set to 1, but we'll actually set it to 2. This web page indicates that that's the effective range for JPEG. We'll roll with that for now. And then frames per second, and the output is the same. So we're just going to hit OK here, or hit Enter, and it's going to create those images. And the difference between adding this Q scale parameter and not having it is pretty stark. And we can illustrate that here real quick. So these are all of the images that we had from a previous run here. So we'll just dump these back in there. All right, and just to illustrate sort of the difference here, I'm going to rerun this without that parameter set. So we're getting rid of this Q scale parameter only to illustrate the difference in video quality here. Okay, so if we pull up any random frame, you can really see sort of the pixelation that's happening in here. We see a lot of squares and blockiness. The image just isn't nearly as clear. So compare that image to this image, and a lot of this is clearer. It's just a much better rendering. So we will, and actually it would be really interesting to compare that to the 720, but I'm not going to waste time doing that. Okay, so I'm going to get rid of all of this stuff and proceed with building the model. All right, so we have all of our images here in this image directory. Now, if you look at this stuff, we'll wait for the previews to come in here and add a preview pane. This is just taking a second. There we go. The previews are going to make this a lot easier, so we'll just wait for those to finish coming in. Okay, so these thumbnails are still not quite done getting generated, but in the meantime, I wanted to show you this first part, which is that at the beginning of this video, you see this white top mountain start tiling in here. And if you look at it by frames, you can see that between frame 30 and frame 31, we've dropped that. And so since we don't want this in our reconstruction and it doesn't take a significant amount of time, that's the first 30 seconds of the video, the drone's taking off. We can just delete those frames entirely. Probably just as easy since we're not going to be losing too much of the data. The next thing that we want to do is we want to find out where these frames break. So if you watch the video, you'll see that this is a sort of a composite shot of several sub-videos edited together. And so if you kind of follow along with the images, you'll see it effectively the drone kind of flying along through the air. I apologize that these haven't fully rendered. It's making this effect much worse. There we go. Move on a little faster. Okay. So far you can kind of watch the trail of this here. This is all one continuous shot, right? Nothing has changed. One shot kind of bleeds into the next. And you can effectively see that drone flying over the terrain. So what we're doing is we're looking for a spot where that changes, and we switch to a new perspective, right? This is all the drone kind of flying along in a single perspective, and you can again watch the trail end of the preview frame here to verify that. Okay. Still flying over terrain. Just gonna roll through those very quickly. So we're looking for that point where the video switches to a new perspective. So I'm going to pause the video here while here we are. So between frame 212 and 213, you see that there's this big jump, right? Those aren't sequential videos. So what we want to do is highlight all of these from the first 200 seconds. And we're going to move those into their own directory. Okay, so we can use this as part of the project reconstruction. I'll get into the second phase here in a second, but essentially you'd follow that procedure to get through the rest of these, and it looks like we don't have too many more frames to go. So again, we kind of follow this along. We have a single progression. This might be the drone heading back home. It's kind of hard to say. But here, 213, all through this section, all continuous footage. The reason you have to watch this is that the computer is essentially looking for like features between frames. And so there's this implication that the stuff you're looking at is sequential. You can actually merge projects together that are non-sequential, but you would do that later. This thumbnail's not coming in, but that's clearly part of the same one. Not sure why the thumbnail's not coming in. You can see here that we have another break coming up, right? Somewhere between this and frame 270, it looks like we are. There we go. We've switched to new footage. So here between 257 and 258, these are entirely different sequences. So we're going to, again, copy and paste this. And maybe that frame's not big enough to do this. It's kind of nice to have a minimum number. And I'm just going to dump the rest of the frames here in folder 3. So we've just gone through and sort of parceled our video out into different pieces. The next thing to do is to try to run Pix4D on those images. So you need Pix4D installed. You can download this for free. We have a license here at Virginia Tech. So if we want to run this, you can run it on my computer if you want. But you can download a trial version as well. Pix4D is pretty resource intensive, so you have to be a little bit careful about that. But you could at least give it a go. So here's part 1. We don't need a file extension. We're going to add all of our images that we just took here. Probably this should have been in the other directory, but I'm not going to worry about it now. So we're going to pull in all of these, however, 182 images, which isn't really all that many. What it's going to do is it's going to go through and try to match a camera model. Since we're extracting from YouTube video, there is no camera model, but oftentimes when you're camera, whether it's a GoPro or whatever else, it's going to tag each frame with information about the camera. So this is called EXIF information, and it's really useful for correctly calibrating the models. And part of what we're doing here is testing how necessary that data is. I'm going to run the 3D maps piece here. It's relatively slow. We're not even going to run all of the steps. So I'm just going to run step 1 for now. Most of the time when you're making a model, you would run all 3. But I'm going to look at the processing options here. It's always nice to kind of, these are, let me kind of go through this. The calculation of this kind of goes in these 3 phases. So this is phase 1. There aren't a lot of things to do here, but we're sort of saying that we want to match all of the key points. This is what we're going to call a free flight. And then the calibration we're going to set to automatic. So we don't have to worry about any of that. But we do want the matching to be free flight or terrestrial. We're definitely not doing an aerial grid or corridor. Okay, part 2 we'll get into here in a second, but this is where the point cloud is constructed. We won't be generating a mesh. We're probably going to set this to 9 by 9 instead to try to get the maximum matching potential. And I'm just going to, I guess I'll just go ahead and run both of these. I'm going to set this to original size and high. Now, these settings that I've kind of cranked up are going to really increase processing time, but they should result in a much better model. So we should get maybe the best quality model out of this that we possibly could. I'm also going to merge all the tiles into one file. I'm going to go ahead and run this initial processing without step 2, and I'll talk about why in a second. But basically, what I want to do is only keep part of the model. I just want to kind of keep what's under the ground and not what's off in the distance. So we hit OK. We're going to start the processing. I've got stage 1 checked, stage 2 and 3 unchecked. We're going to go ahead and run it. And it is going to process this data, and we'll be back when that's done. Okay, so stage 1 is done. Before we calculate stage 2, which takes a little bit longer, I wanted to take a look at this point cloud. So what you see here is a rendering of what that drone saw during its flight. And I'll move this. You can kind of, navigation can be a little bit tricky here. Oops, let's zoom. Okay, good enough. So what you're seeing here is if I'm zooming in on it here, you can see the sort of switchback trail, the top here, and the flight as it goes through. This is showing the camera angle, and then obviously it's picking up a ton of stuff over here, right? That drone was pointed to the pointed forward, and so it was picking up a lot of background information as well while it was flying. So what we want to do is really just sort of set up a bounding area here to only calculate all of this stuff, because we don't care about, this is all junk, right? We don't want any of this data in our model. So what we can do is go up through our image. So we'll go to map view. Oh yeah, none of this is geolocated, so we can't do it that way. We'll go back to the rate cloud here. What we want to do is set a processing area. So new processing area. Okay, so we have processing area selected, and we're going to try to select just our piece here. Oops, that didn't work at all. All right, so we're going to escape out of that. All right, let's try this again. New processing area. All right. Well, most of the time you can do this in the map window. I will leave that problem for a future somebody else to worry about. So I'm going to uncheck that. And we're just going to go ahead and run part 2. So just to verify those settings, if we go into processing options, we've got set it to original, to high. We're not generating a mesh. We're setting this pixel size to 9 by 9. I'm not going to classify the point cloud because this is going to get too messy anyway, and I want to merge all the tiles into one. So we're going to hit OK. And it's going to proceed through and do just that step. I'm going to pause the video while that finishes. Okay, that piece is done. We can look through this to get some information about how this worked. The number of points that we're getting out of this is about 16 million. Not all of those are going to be usable. Average density is 236 points per square meter, cubic meter rather. So let's take a look and see how this worked out. So I'm going to use a program called Cloud Compare to take a look at this stuff. It's kind of a go-to software for this kind of thing, especially for just quickly visualizing and manipulating point clouds. There's really nothing better. The data that you write, so we had written this out to part 1. I'll probably move that into the White Top Mountain folder here. But if you go into the densification folder, you've got a point cloud, and this is a LiDAR file with the .las extension on it. So we can just drag and drop that in here and hit OK. So there are 16 million points all coming in, and this is what we get as the output. So we weren't able to define the boundary in Pix4D, which we might have ordinarily done. It looks like we've got some misalignments here, which is bad. And if we zoom in on this portion, we've got something that looks slightly better. We'll probably need to go in and repair some of this stuff. So let's take a look at how we do that. Just as a quick example here, we can pretty quickly section this stuff off. So we're going to use the scissors tool and just kind of keep only this stuff here. Right-clicking to finish it off, and we'll keep only what's inside there, and hit OK. That actually just divides the cloud up, but it's a nice way to sort of just get at the pieces that you're interested in here. You can see that we've got some more errors. I don't know enough about the study area to know whether this is real or not. Clearly that's not. If we wanted to get rid of that stuff, we can use the scissors tool again. And we'll do this in multiple steps here. So we'll section that out. And then if we hit this unpause button, we can actually continue to carve pieces. So we'll section that out. Hit pause again here. A lot of this stuff is just stuff that probably came in from the sky. So it's not good data here, but you can see it all kind of showing up underneath. And just a little bit more here. Whoops. So you don't necessarily need to do this to work with the LiDAR point cloud data, but it often makes things look quite a bit nicer. We'll hit the check mark here. So it looks like it didn't do anything, but actually it split it into these two pieces. So now we're left with this. Now keep in mind there's no real orientation information here, so that part is bad. And we've got our switchback here kind of winding down, following the route up. And then this is almost surely errors associated with the image. So when we do scanning surveys, we typically point the camera straight down or just slightly off nadir. In this case, we're shooting video, which is actually quite common for anything you'd find on YouTube, and so it's projected outward. Which means that a lot of this stuff is really no good and not useful. But most of this stuff should be. If the orientation were correct, it would probably look maybe something like that. And we can do things like add in shading. That might make it look better or worse. That looks a little worse. Okay, so there's just a quick introduction. Obviously, this isn't the best reconstruction. We could go back into Pix4D and look at some of the cameras and see how they did. You can see that the positions here, the cameras are quite off. It might take a little bit of jiggling around to kind of get into where this is supposed to be. But you can see that we've got a couple of cameras that are sort of misaligned out here. So if we look at this image, some of that's coming in from here. We can actually do things like uncheck those. So we could get rid of some of these images that are potentially causing problems. Usually they're all sequential. We could go back in and fix the positions. So that one actually looked maybe good, maybe not. Actually, probably not. Those look maybe okay. That one is bad. That one is bad. That one is bad. And we know this because these images, we know that this flight was taken more or less in sequence, and so we know that probably those images are incorrect, unless some footage got spliced in there that we don't know about that didn't do a very good job. But that's probably pretty close. We have this stack of images where the flight is also doing something kind of peculiar. We could kind of go in there and see if we could figure out why that is. So we've got this one. The dots here are key points that it's located. We can look at this one. So if we kind of move through these in order, starting with this one. So that's camera 191. Then we're moving forward. So that looks like it's moving forward. There's a good chance here that the sky is causing problems. So we could go through and we could mask that off as well, as we've talked about before. But we could also just eliminate all of these three and only keep the stuff that we see back here, which would still be well over 100 images. So probably enough to get a pretty good idea. Just to check that out. There you can see us moving through. We've got our common key points here as we're co-locating our images. There we're turning and flying back. Here we go. So the real problem here is really these images, and the reason you know that is actually if you look underneath, there's the span of all of our images. So this is a much better sequence. All of these are essentially broken and misaligned. So you could go back in and fix them, but again, what I want to do is just remove them to make for a better point cloud. It could be that these are, there was a break in the video that I didn't detect. It's hard to tell from this just by itself, but definitely all of these images are bad and leading to reconstructions, right? This is not where the drone was. So you know that these images are not doing what they're supposed to be doing. Okay. All right. So we've excluded a handful of our images. So we're going to go ahead and rerun this again. And I'm going to exit out of Cloud Compare before I do that. So we're just going to rerun step 2. Step 1 is still fine. We've got a problem here with these folders being open. So I need to exit out of this here real quick and hit OK. Okay, so it's reprocessing and we'll be back again when that finishes. Okay, the rerun with those cameras removed is done. So this is the output here. You can read through this. It took about 20 minutes to complete. On my machine, probably more on some other ones. This one is has a lot of memory and processor cores, so it does run pretty quickly. We still didn't specify the mapping area, so that hasn't changed. That's still going to be a problem. But hopefully a lot of the kind of junk that showed up here is gone. So we'll just trim this out again using our scissors. All right, and we could go through, it's probably not super necessary, but we could go through and trim that out as well. It probably won't affect the model too much right now. But overall, I think what we got is a much better look. You can improve the rendering if you calculate the octree. So if you go here, you can calculate that. What that's going to do is it's going to kind of bin the point cloud up into pieces. So that's what's going on down here. And then you're not looking at the things, or it doesn't try to render the things that you're not looking at. So you'll see that the overall rendering speed has improved a good bit. Some of this is actually kind of visually distracting, so why don't we just slice it out real quick. Okay, So yeah, I think overall this model worked pretty well. You see like a change in illumination probably right here. I don't really know much about this environment, but I think it did a reasonably good job of reconstructing the pieces here, especially for video that we didn't capture ourselves. Okay, that's it. Thanks.